So let me draw. Make sure to draw this. Let me draw that. Then I'm going to draw something. Remember, all this is kind of a review, but then we're going to fit it to calcium channel blocker. Okay, and then I'm going to draw a fourth one. And of course, I'll name what these things are in a second. And this, what I do on this will be a little, it's on a slide with new information. So this is going to be two action potentials, okay? So this is going to help reviewing too. So this is going to be the action potential of contractile cells. So this is potential of those cardiac contractile cells, 99%. This is the action potential of the autorhythmic SA node, etc. Okay, this is going to represent when we talked about actually cardiac muscle contraction. And here, this will be vasoconstriction. And all of them will involve calcium. So, again, when we review this, which we're starting to review this, we kind of did a 1, 2, and 3. Okay? And again, where is this? So, yeah, make sure we see one. So remember, this is action potential of the cardiac contractile cells. So we're back on action potentials. Again, what do we call when you're sort of going from negative to more positive? We call that process depolarization. So this helps us start to review already. And again, depolarization in this case is caused by what? Influx of what? Sodium. We're staying with sodium on this one. Depolarization, we're going to have sodium channels open, sodium influx, kind of like we did the previous section. I'm going to write sodium in. When we look at 3, and we're coming back down to where we started, we call that repolarization, and we don't have polarizer. And what is causing repolarization? Potassium. Potassium going out. Okay? So potassium out. Okay? And repolarization, again, potassium efflux. You see that on the test, it's going out, influx in. Okay, and that's normal. Okay? But when we looked before at the skeletal muscle and we looked at the nerve, the repolarization happened right away. Here we have something called a plateau, because we extend the depolarization for like 200 milliseconds instead of just a couple. So with the plateau, which is number 2, we had 2 sort of factoids, so to speak, of it. One was the purpose, okay? And the purpose was to prevent, again, if you had skeletal muscle, if you you could have many action potentials and form tetanus. We do not want tetanus in the heart, so we extend the action potential so that the next one would have to be as the cardiac fully came back to normal. So kind of just the idea prevents heart tetanus. Prevents basically creating where you basically have just close the heart and it won't pump out any blood. Because the next, the muscle will contract and relax at this point, and basically before the next one can occur. But the idea and how to get in this is, what is going to cause this to stay positive? So we're still going to have basically, 2 up there. We're gonna have potassium out. So potassium channels already are opening, positives going out. But what is happening to keep it sort of, instead of positive coming out, anything would happen to be negative. What's gonna keep it there? Calcium is gonna come in. Potassium's going out, but calcium channels are open coming in, and that means the overall charge can stay about the same and create that plateau. So potassium out, calcium in. That's what's keeping this. That's what's creating the plateau to make sure that we stay long enough that the heart then would fully relax before the next one happens. Cool? Yeah.
I don't really understand how, the plateau makes it so that the heart can fully relax.
Because the idea is, and I could put the picture up. Could do that because it might be just easier to just illustrate it instead of me just where is this? I want. This was back and forth.
No, not those.
Might not be
Oh,
bad to
that's
have
on the
this up.
pacemaker. Yeah, that's on the pacemaker. Okay.
Come on, baby. Yeah, I'm gonna nasal. What do I have to do? I don't know what that means. Leave me alone. Okay, let's go to when we actually showed it. All those heart valve stuff you have to know, all that's cool. I'm going to do that one in a second. Okay, so this is sort of where it is. So this is kind of what the picture we have, except I don't write permeabilities, I write this, right? It's the same idea, just they write a different format. Again, you can see there's a slight drop, but here's sodium in, here's the balance of potassium and calcium, and then the idea, forget the calcium channels, potassium win. So you're extending a couple hundred milliseconds to answer your question, or just to visualize it, sort of the idea of this. Wait, no, I went the wrong way. No. So, and this was skeletal muscle, right? For skeletal muscle, it took, 100 milliseconds to go. There's the action potential. The whole problem was that if you had action potentials in the middle before it fully relaxed, you're going to get more and more and more tension of the tendons. If you look at the idea of cardiac, okay? So here is the action potential, but in order for the muscle, the cardiac muscle, it takes a couple hundred milliseconds. So the idea is it's going to take time to contract and relax, but we're not going to allow another action potential here.
Because it's already at that level.
Because the plateau basically makes it so, because you can't have another action potential until we come down here. Okay, so if we just had it before, it would come down, you could have more. So they extended this to match the time it takes for the cardiac muscle to contract and relax.
Okay.
Kind of cool. So kind of this idea to prevent tetanus. Okay, so if you look at this, I kind of want to put it here, let's see, just for this one. Overall, if you look at a calcium channel blocker, because that's kind of what we're doing here. So, this I'm not even going to relate to blood pressure. I'm not going to slide this going to do it. But a calcium channel blocker, if you put a calcium channel blocker, what is that doing to this, or what's going to happen?
It's going to stop the calcium.
Okay, well, what is literally going to happen? What's going to happen to the plateau?
It's going to go away.
Right, decreasing. So you're going to lose the plateau, or decrease. Plateau. Actually, let's go ahead and put calcium in, sort of equaling potassium out like I have up there. So you're losing the plateau, and therefore you could end up having heart tetanus. So you could increase, the idea of tetanus. But I mean, you might be controlling that. But the effect of that could be in general to decrease the length of the plateau, and it could cause a problem. That's that. Let's look at all three of these things. See how they might get here. far as calcium channel blockers. So 1, 2, 3. Go ahead. 1, 2, 3. This is in the pacemaker cells, okay? And the idea is to put a threshold here. So 1, 2, 3. So what is causing the slow depolarization, if we remember, to threshold? Are they funny?
Yeah,
Funny,
funny
aren't they?
channels.
Funny channels. And since we do have the PowerPoint up, I'll go ahead and show these. Okay, there's kind of picture of it. And so the funny channels are sodium, potassium, and where is, go ahead, so it's kind of the bottom there. So funny channels are leak channels. And again, leak channels have this idea of potassium leaking out, sodium leaking in, but we're coming closer and closer to threshold. So these channels are basically allowing, sodium to leak in, it's more permeable to sodium, to leak in more than potassium out. And that's going to allow us to get to this threshold, but you don't have to know the numbers for it. So these funny channels, I don't know why they named it, are really basically sodium potassium leak channels. Sodium is leaking in till you get to threshold. And now we're on this, I should have not done it, but what's causing the depolarization for the autorhythmic cells, which is 2? What ion's doing that?
Calcium.
Say again?
Calcium.
Calcium. So unlike all these other action potentials, depolarization is caused by calcium influx. Again, that's still positive coming in, okay? That's gonna work. Calcium influx. And again, what do we call number 3 when we're coming back to where we started?
Repolarization.
And it's by the same kind. Polarization. It's going to be caused by potassium going out. And remember, this process is basically, this rhythmicity is contributing to heart rate. Okay? The idea is, they get closer, it's faster heart rate. If it's not having as much, it's lower heart rate. With that said, if you're given a calcium channel blocker, what do you think? You see what it's affecting it. What do you think that's going to do to heart rate?
No depolarization.
Which means what's going to do overall to heart rate?
Flatten it.
It's going to what?
Flatten it.
Well, remember, think about, okay, if you kill the person, yeah. But let's think about a smaller dose. What is it going to do to heart rate in the sense of increase or decrease heart rate?
Decrease it.
It's going to decrease heart rate. And what's that going to do to blood pressure? You see why I turned to back page, okay? Students low blood pressure. The idea is going to basically decrease blood pressure, okay? And you will, of course, have the baroreceptor response, but I just put it up there. Okay, let's go to this, the next one, and we'll kind of get this together. And now I'm going back in where the PowerPoint was. That had to do with this, okay? And so this represents cardiac muscle contraction. And the whole idea of this was, we're going to use extracellular calcium, okay, through a calcium channel. That's going to trigger intracellular calcium as well. And the big factoid here, which I put before, is the more calcium that stays inside these contractile cells, more calcium basically creates a greater force. Remember that back in the day, a few weeks ago, of contraction. Okay, of course, I guess I put, but I won't go into the details for today. We get calcium out that we pumped in. This is extracellular calcium going through a calcium channel, okay? And again, the more calcium, the greater force of contraction. So, we use a calcium channel blocker. I guess we get this. What is that going to do to the force of contraction? Decrease force of contraction. What does that do to blood pressure?
Decrease it.
Decrease, you see it over there, right? Force of contraction has to do with stroke volume. You're going to end up decreasing blood pressure. And of course, you will have a baroreceptor response.
Does it block both the influx and the efflux, and is the influx like higher concentration gradient? Is that why that
The-
effect is happening?
It only block the calcium channel that it's blocking for these are going to be the influx.
Only?
Yeah. Okay. I don't think, because this has a different transporter. You know, if you look it up there, I don't think it blocks the. And that's the thing. It doesn't really block, because that's an efflux thing. So it's not really blocking that, but it is blocking the influx, which is going to decrease this force of contraction. And therefore, decreased blood pressure. Of course, you will have a baroreceptor response, and we'll look at that in a second. So here, yes, sorry.
Now, why wouldn't that drop the heart rate?
Well, it does.
Oh, okay.
Here.
So but I
So-
mean on the cardiac muscle contraction.
Because the cardiac muscle contraction, affects stroke volume,
Got it.
right? That's the ESV part.
Okay.
So we're going to get to how everything, the calcium channel block everything, but yeah, we're showing you specifically how calcium channel blockers will affect these different things. Heart rate, boom. Also now, we're already on the idea of, and we'll get to this idea of force of contraction, okay, has to do with, stroke volume.
Okay.
And that's how that's lowering blood pressure.
So that's okay. I see.
How about the veins and arterioles? Okay, so the idea of this is, so these are the veins, arterioles, and vasoconstriction. And this is sort of was on another slide, but I'm putting it on now. The same thing on this, and we'll see this. When you actually put more blood in, what's happening is almost like the heart. Calcium enters. Okay, so as blood is coming into vessels, basically it's stretching. This is kind of another stretch receptor. Calcium enters. And it's the same way. Although we look at the mechanism, you don't have to look at the internal. The more calcium, and it's not in the blood, it's in the smooth muscle, but I have to write it. But it's the same way. The more calcium that gets in, which means the more stretched calcium that's in, that's going to then cause vasoconstriction. So it kind of works similar to cardiac in that sense of how that it is kind of stretch receptors. And again, how the stretch receptors are working to cause more contraction is as they stretch, calcium comes in, and then calcium is going to create a greater force. So the more calcium that gets in, vasoconstriction. So guess what we're going to do? Calcium channel blocker. So what it's going to do to the vessels? Cause what? Vasoconstriction and vasodilation if we block it.
Vasodilation.
And what is that going to affect?
Blood pressure.
In your lower blood pressure, you're going to have a
Baroreceptor response.
baroreceptor response. But do you see how interesting this drug is? So when we were doing alpha blockers, we had an overcompensation potentially on the beta side. When we did beta blockers, we had an overcompensation on the alpha side. This is an interesting drug because it kind of works on the beta receptors and the alpha receptors sort of equally in a sense to lower the blood pressure. So I'm not saying that's a drug you use, but when you look at calcium channel blockers, you might have less of that effect of those two plates of one overcompensating because it literally is affecting that. Are you going to still have more norepinephrine flying around? Yes, because the baroreceptor response when you lower blood pressure will happen, and that means baroreceptors respond, lower sympathetic, increased para, but now we have a little more action on several of these things. there's still other ways that you're gonna have compensation, but you still have the baroreceptor response. But everyone see, now you've got it on several different avenues here, on kind of both sides of the coin. The vessels and the heart are sort of being affected by the calcium channel blocker, okay? Now, I'm not putting this one, how this affects blood pressure, as far, because it obviously affects sort of the length of this, is a little more wanky. I don't want to wank us out. It's already hard enough as it is. So you're not gonna be like, there's the question on calcium channel blocker that's involving the contractile action potential. It's really going to be involved, in losing the plateau or or increasing tetanus. I'm not going to do any blood pressure thing on this. But I am going to have questions on calcium channel blocker. Multiple choice questions, potentially. And really a lot of these for those drugs can be even digitalis, which I'll probably look at again before we potentially stop. They're going to be multiple choice. I'll basically have like symptomology. And then I'll have 4 or 5 sort of drugs that are involved there. And you'll say, that's a beta blocker, or that's an alpha blocker, or that's a calcium channel blocker, based upon some of these characteristics. So remember, on some of these things, you're going to have to know them. I'm going to put pictures on them, these various things, how they affect, ions in and out. But also, I am going to apply these to basically blood pressure and the baroreceptor response as well, okay? And that's why, especially this, because that was on a slide that we just, I skipped to just show this part, that we didn't really have. Does everyone sort of see calcium, 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 calcium? So for cardiac especially, calcium is sort of one of the key ions. But again, that means calcium channel blockers in general are a potential, drug for high blood pressure as well. And there'll be other side effects as well, but it's kind of an interesting one because it does cover both sides of the coin. So this is for the practice questions or something. I don't know how many did it. I wanted us to do this. I wanted you to do it, but really I was like, let's do. I always want to do this one in class. So the other ones, because it will help you on some of the multiple choice. And again, after we do lab, it won't be tremendously long. I'll stay and do a review. I don't think I'm supposed to see my granddaughter tonight. My son was out of town several days, so Ola needed us more. I was like, yes, so we went over a few days. I got to see her 3 days in a row. So my son's back, and that means my kid won't want to see me because it's dada. So I probably have time today to stay as long as you need, okay? You can see I'm on to in grandparent mode here, so I can't help myself. Okay, let's stop, and I'll see you 12:20.